Hello everyone, I am PL Meenakshi, Assistant Professor, Department of Mathematics, St. Josephs College of Arts and Science for Women. In this section, we see that the theorem, Jordon Theorem, in real analysis. First, we see that the statement if G is of bounded variation on 0, del, then limit alpha tends to infinity 2 by pi integral 0 to del g of t sine alpha t by t into dt equal to g of 0 plus. Proof. We consider the case to prove the theorem. It suffices to consider the case in which G is increasing on 0, del. If condition alpha greater than 0 and 0 less than h less than del, and we have the integral value 0 to del g of t sine alpha t by t into dt. We split into the integral into 0 to h plus h to del. So 0 to h g of t sine alpha t by t into dt plus h to del g of t sine alpha t by t into dt. Next, we add and subtract the function minus g of 0 plus g of 0 plus. So we get 0 to h g of t minus g of 0 plus g of 0 plus sine alpha t by t dt. Next, same this integral value. Next, we split into the integral g of t minus g of 0 plus sine alpha t by t dt. Next 0 to h g of 0 plus sine alpha t by t dt plus h to del. So we consider the integral I1 of alpha comma h, second integral I2 of alpha comma h, then third integral I3 of alpha comma h. We find the values of these three integral values. First, we consider the third integral I3 of alpha comma h. Using Riemann-Lebesgue lemma to I3 of alpha comma h, we know that the Riemann-Lebesgue lemma limit alpha tends to infinity integral I f of t sine alpha t plus beta dt at value 0. So apply this Riemann-Lebesgue lemma, this integral value tends to 0. Also, take the second integral value I2 of alpha comma h. So that is g of 0 plus 0 to h sine alpha t by t dt. We substitute the limit to change the values. So take alpha t equal to y, then t would get the value y by alpha. Then dt equal to dy by alpha. So we change the limits also. T tends to 0, then implies y tends to 0. T tends to h, then implies y tends to alpha h. We put the values. So 0 to g of 0 plus 0 to alpha h sine alpha y by alpha divided by y by alpha into dy by alpha. Next, g of 0 plus 0 to alpha h sine y by y dy. We know the value integral 0 to infinity or 0 to anything sine y by y or sine alpha by alpha. So value is pi by 2. So this I2 of alpha comma h, we get the value 0 of 0, g of 0 plus pi by 2 as alpha tends to infinity. Next, we find the first integral I1 of alpha comma h. Next, we choose one positive integer m greater than 0 because g is increasing function. So G is also a bounded function. So by using bounded definition, integral a to b sine t by t dt less than m. It follows that integral a to b sine alpha t by t dt less than m. Next, choose g is increasing function. So by the definition, modulus g of h minus g of 0 plus less than epsilon by 3m. And also g is an increasing function. So g of t minus g of 0 plus greater than or equal to 0. Then we apply the Bonnet's theorem. So 0 to h g of t minus 0 g of 0 plus sine alpha t by t dt. So apply the Bonnet's theorem, substitute the limit and get the value outside. So g of h minus g of 0 plus integral c to h sine alpha t by t dt. The definition of h gives, so taking modulus on both sides, so modulus I1 of alpha comma h, so modulus g of h minus g of 0 plus modulus c to h sine alpha t by t dt. So we apply the values of these two values, two functions. So less than g of h minus g of 0 plus less than epsilon by 3m, then this value is less than m. So cancelling m, so less than epsilon by 3. So we know I3 of alpha comma h, I2 of alpha comma h, then I1 of alpha comma h. Put these values into the main function. So modulus integral 0 to del g of t sin alpha t by t dt minus pi by 2 g of 0 plus equal to modulus, taking modulus these functions. So less than or equal to I1 of alpha comma h plus I2 of alpha comma h minus pi by 2 g of 0 plus I3 of alpha comma h. Substituting these values, so less than epsilon by 3 plus less than epsilon by 3 plus less than epsilon by 3 less than epsilon. So taking limit, so equal to 10 tends to 0. So this minus value goes to equal side, get plus value, so pi by 2 g of 0 plus, so we get the equation limit alpha tends to infinity 2 by 0 to tell g of t sin alpha t by t dt equal to g of 0 plus. Hence proved. Thank you.